Hey guys, welcome back. I hope you had an opportunity to watch all of the related rates videos that are on my YouTube channel. And now I'm going to do the shadow lamp problem. Okay, so basically the shadow problem is as follows. There's typically a man who's walking away from a building or towards a building. And a lamp forces a shadow to be cast or whatever. Um, Here's the building in both of these pictures, okay? Now, if the man is this line here, okay, and the light is here, here's how I want you guys to do this. If the person is walking away, so the person's walking away from the uh, building, then the person's walk, I'm going to call X. And this piece I'm going to call Y. This piece here that I just called Y is going to be the shadow, okay? And if the person, so that means dy dt is the rate of the shadow changing, the rate of the length of the shadow changing. So the rate of the length of the shadow, okay? Now, if you guys do this, then you're never going to have trouble with this problem. Dx dt is going to be the rate the person is walking, the rate the person is walking, okay? Now, one thing with this type of problem is that you're always going to have a constant. Maybe the building, the distance between the light and the building is a constant, or the height of the building is a constant, but we'll figure it out with respect to the problem. Okay, I kind of switched my triangles around, but I really wanted both of them to be an opposite. So if you're walking towards the building, it doesn't matter. If this person right here is your height and you're walking towards the building, then just say the walk is behind the person and the shadow is in front of the person all the time, okay? So that's if you're walking towards the... Now, dx dt and dy dt is what we're going to call the tip of the shadow. It's going to be the whole thing, okay? So let's take a look at a problem. So in this problem here, as you can see, there's a man who is some feet high, tall. So the person is 6 feet tall. And that person is walking. So let me do this really fast. Okay, so that person is 6 feet tall. And they're walking at a rate. Now remember, as they're walking, I want you to put that behind the person, okay? And if you could zoom in on the shadow, you'll see that the shadow is really dark on the floor right there, okay? So the person is walking, so we're taking a look at this problem here. A man 6 feet tall walks at a rate of 5 feet per second away from the light that is 15 feet above the ground. Okay, so the light is right there and it's 15 feet. So I have 15 feet here. I have x here, y here. I have dx dt, and I have dy dt. Okay, remember that this is the shadow. So we're going to call this shadow. And this is the walking. Okay, now dx dt is 5 feet per second. And it says, when he is 10 feet from the base of the light. So here's the 10 feet. Now, when you are doing this you should read as, at the instant he is 10 feet. In other words, I don't want you to plug in the 10 feet until the very end. So when he is 10 feet from the base of the light, now here's part A. It says, at what rate is the tip of his shadow moving? And here's part B. At what rate is the length of the shadow changing? I'm going to do the length of the shadow changing first, okay? So let's do part B first. Okay, so we're looking for dy, dt, okay? The length of the shadow. I'm going to do part B first. So 15 feet is constant and 6 feet. Here's what I want you all to do. I want you to set up two proportions. Okay, I want you to set up 15 is to x plus y, as 6 is to y. Okay, so 15 is to x plus y as 6 is to y. Then we're going to cross multiply 6x plus 6y. We're going to subtract the 6y and we're going to have 9y equals 6x. I'm going to take the derivative right here. Derivative of 9y with respect to t is 9 dy dt. The derivative of 6x with respect to t is 6 dx dt. We know the rate at which the person is walking. So you have 9 dy dt equals 6 times 5. Now we're going to divide by 9, and we're going to get 30/9 or 10/3. So that's what dy dt is. The reason why I did this before I did part A was because in my previous slide I said if you take the rate that the person is walking plus the rate that the length of the shadow, right? So this is the length of the shadow. This is the rate of the length of the shadow changing and the rate of the person walking, and you add them together, you basically get part A. So part A, they want you to get the entire thing, and then part B, they wanted you to subtract the 5 feet. So all you have to remember for this problem is to set up a proportion. Remember, behind the person is the rate of the person walking. In front of the person is the shadow. Okay? Remember that you need a constant. So I have another problem, and if you guys feel solid about this, then you can stop watching.